Well, this is a typical industrial pressure switch. We monitor pressure through this on the bottom. These are standard 1/4 inch NPT threads, and it supplies pressure to the bellows, which is located down below. We'll take a little bit closer look at that in a second. This is the electrical portion up above, and we'll also take a look at that. So the mechanical connection is made down here at the bottom. The electrical connection, if we take a look at the top of the housing, there's already a pre-drilled hole for a 1/2 inch conduit connector of some type. So the bellows is located down below. If we take a little bit closer look at one that's already been disassembled, we can see what that bellows looks like. Think of it much like an accordion, which expands and contracts with pressure. This is the bellows, and pressure causes this bellows to operate against spring pressure. As the bellows moves up and down inside the housing, it operates the set of contacts which are located up on top. So let's take a look at this other pressure switch in closer detail. The ratings on this pressure switch, we can adjust the point at which it will operate on decreasing pressure anywhere between 3 to 150 psig, it tells us. It has a maximum operating pressure of 475 psig, and it's UL listed, which is important to us. So next, let's take a look at the insides of this. So we loosen the screw on the top and take a look on the inside, and here's what we have. We have an adjustable nut in order to set the operating pressure, and there's an indicating arrow and right here that tells us what pressure we set it at, and we can just simply take a screwdriver and adjust that as we need to. The contact block, electrical contact block, is located on the top of the unit. This is the differential screw. This pressure switch, we said, operates on a decreasing pressure. So let's say we set it to operate at 120 psi. We want the air compressor to kick on at 120 psi. So when the pressure in the system drops to 120 pounds, it's monitored through the pipe fitting down below and into the bellows. That causes the contacts to actuate. The normally open contacts would go closed to start the air compressor. Now, we don't want these contacts to open back up again at, say, 120.5 pounds or maybe 121 pounds. We'd like pressure to build up in the system before these contacts operate again. Though, granted, we'll be using a separate pressure switch in order to shut the compressor off. So what we can set is what's called the differential. By adjusting this screw in a clockwise direction, we can increase the point at which the pressure switch will reset, and that's called differential. On the top, there are three contacts, or three terminal screws, I should say, for the contact block. The far left screw is labeled C for common, and then the middle one is labeled NC for normally closed, and this one on the far right is labeled NO for normally open. This is a single pole double throw switch, meaning that we can bring power in on one single pole on this common terminal screw, and then the power will go to either the normally closed or the normally open terminal screw. When the switch operates, the normally closed contacts will open up and the normally open contacts will go closed. If we need to replace this contact block, there are two small Phillips screws on the top that we could easily replace the contact block if we needed to. One thing that we can do with this pressure switch is we can manually operate it. If we turn it to the side and we look right in the back, there is a little lever that's actuated by the bellows from down below, and we can actually take and move that with our finger and operate the contacts. So we could take and put a meter on this component and check and verify that the contacts do in fact operate as they should. Well, let's go through how we check this component out in the field. I've got my meter set up to read resistance. I'll go ahead and verify that my meter does operate on resistance. Touch the test leads together. The meter beeps and it goes to 0 ohms. I take one test lead and I put on the common terminal screw. I take the other test lead and I put on the center terminal screw, which is the normally closed contact. My meter beeps, goes to 0 ohms, indicate that contact, the normally closed contact, is functioning properly right now. I leave the black test lead where it is on the common and move the red test lead to the normally open contact, and my meter stays on open circuit, OL, indicating that that contact is in fact open. Now, as I said, one thing I can do with this switch is I can go ahead and manually operate it. So I reach around behind while I hold the test leads on the common and the normally open contact, and when I operate the little lever in the back, the contacts change state. The normally open contacts just went closed, the meter went to 0 ohms. I can also verify proper operation of the normally closed contact. It's closed right now in a normal position, but if I push down on the lever in the back, that normally closed contact will open up. So my contacts are operating properly. Looks like a good industrial pressure switch then.